Hey everyone, welcome back to our continuing discussion of intelligence testing. This time we're talking about the principles of intelligence testing. So we're going to talk a bit about what makes a test a good test. Well, first let's distinguish between the two different sorts that we're going to discuss. First is an achievement test. This measures a person's level of knowledge, skill, or accomplishment in a particular area. So it's how much you know about something. So for example, when I give you the final exam for this course, it will test your achievement, your knowledge, your skill or accomplishment in the field of psychology. How much have you learned during this course? That's an achievement test. By contrast, we have the aptitude test. This is meant to assess a person's capacity to benefit from education, or training. So perhaps when you're going through school, you were given tests that ranked you on your aptitude. These were sort of not dependent on things you know, but were more about your ability to deal with novel problems and situations. Things like the SAT and ACT are aptitude tests. They're not asking you, things you learned in high school, but they're sort of trying to assess your ability to perform at the next level, your aptitude to benefit from what's to come next. So achievement is what you know already, and aptitude is what you could possibly learn. How much can you grow? Let's talk about a couple of important elements of a good test. The first is standardization. Has the test been implemented to a large representative sample under uniform conditions to establish norms? So we can unpack that, right? We want our test to be distributed to a large number of people who are representative and ideally diverse under very, very similar or identical testing conditions. This will establish norms. So basically a population that we can compare our scores to, right? Your score on a test is pretty arbitrary, right? What does 75% correct mean? It means one thing if everyone scores 100% on this exam, right? Then 75 is a bad score. But if most people only get 20% correct, then 75 is a very good score. You need to have a sample to compare the score against, or it's pretty meaningless. Is the test reliable? This means, does it produce consistent results when it's administered repeatedly under similar conditions? So if, for example, you took the ACT twice and you had similar scores both times, that would mean the ACT is a reliable test. If you took it twice and you had wildly different scores, then it's not very reliable. So if the average person who takes the test and takes it again later doesn't have a score that resembles their first score, it means the test is not reliable. It doesn't produce consistent results. Next up, is your test valid? Does your test measure what you intend it to measure? This can be measured in a couple of different ways. We're not really going to get too far into the weeds with different types of validity, but some examples might be, let's say you have a new test that's supposed to be similar to the ACT and SAT. Does this match existing metrics, right? If you're measuring something similar, do other things that also measure that same thing match up with it? Does it measure the intended concept or idea? Another concept would be, does it have good criterion validity, right? Does it predict your success on some criteria? So, for example, going back to our friend the ACT once again, if the ACT is supposed to predict how well you do as an undergraduate, does it do that, right? If you get a high score on your ACTs, do you do well in undergrad? Do you get good scores there? If you do, it has good validity, right? It's testing what you want it to test. And if it doesn't, it has bad validity. It's not testing what you want it to test. Okay, let's talk through these examples, or these concepts with some examples. Okay, let's talk about how standardization works, and specifically how we can use information about a large group of people to determine what our score means. Okay, so you get this large and representative sample of people, and you give them all your new test, right? An aptitude test of some sort. And everyone gets a score, right? Let's just do the scores in percent correct, right? Maybe we get somebody with 97%, a 15%, an 80%. We keep giving these out, 68%, 95%, 82%. We have a whole wide distribution of scores here, right? So what does this mean, right? Is a 97% a good score? Is a 15% a bad score? Is 15% a really, really bad score? Is it just kind of a bad score? How far different is it? So let's follow these three examples. We'll take this guy here, scored a 97%. This lady over here who got a 70%, and this dude back here who got a 15%. And let's see if we can learn a bit more about what they mean in the context of the larger sample. So we can say, if we run the numbers on this, our mean from all of these scores is 70, and the standard deviation is 23. The standard deviation is just a measure of the variability of the scores. right? We talked about this a little bit earlier, but a standard deviation is basically, on average, how far are the scores from the mean, right? So the more tightly packed the scores are, so if everybody had a score that was within 5 points of 50, it would be a very, very small standard deviation. And if the scores are very spread out, like they're all over the map, you'd have a big standard deviation like we do here. So intelligence scores and things like it are often normalized. They undergo a process which basically takes the value of your test, compares it to the average of the population, and then divides it by the standard deviation. So that equation considers basically your relationship to the population and is influenced by how variable the sample is. This produces a nice normal distribution with scores that are now expressed as basically a function of how far that individual score is from the mean. This really just accomplishes having a nice way to compare an individual score to the context in which that score falls, right? It gives you a bit of information about how relatively high or low that score is compared to the population, which, if you recall, is the whole point of IQ tests. So just to jump ahead a little bit, this is how the WAIS IQ score is distributed, right? It's a normal distribution, just like the one we're looking at in our example, except the IQ score values have been engineered so that they're easy to interpret, right? 100 is the average, 115 is one standard deviation above, 85 is one standard deviation below. Okay, back to our example. So let's say we have those numbers from before, those participants who were kind enough to take our new IQ test. Let's see exactly what those scores mean. So the first guy here, he scored a 15% on the test. Based on his score relative to the others, a 15 is 2.4 standard deviations below the mean. So he would fall here on the curve, about in the bottom 2.1% of the population. So that's a very bad score, right? It is over 2 standard deviations below. There are very few people who do as poorly as our friend here did. Okay, what about the next person? This lady scored a 70%, and as it happens, 70 is the mean. So she falls in this region here with most people. So plus or minus 1 standard deviation comprises 68.2% of the population, because that's just how a normal curve works. So she is, like most people, in the middle. All right, what about our last participant? They scored a 97%, which is almost perfect, right? So you might think that that would be on the same end, right? It'd be extreme, perhaps even more extreme than our 15%, but that's not the case, right? This person falls right here, about 1.2 standard deviations above the mean. So what does that tell us? Basically, what it tells us that on this little test that we've made, it's more common to do well than it is to do poorly. So our distribution is skewed a little bit, right? We have a kind of a bad test, right? You can get a nearly perfect score, and the difference between, this percentile here and all the way in the tail distribution is only a matter of a couple of points. So it's not a very good test. It's not very sensitive to the higher end of the distribution. So yeah, this is why it's so important to put tests like this into a context, right? The value of 70% means really nothing on its own unless you compare it to other people, at least in terms of intelligence testing, right? You might think that a 70% accurate score might be pretty high, but as it happens with our sample, it's just right in the middle. And a 97% is also not terribly high just because of how everyone else is doing in the exam. So that's not that remarkable of a score, right? So that tells us more information than just the raw score itself. All right, let's talk briefly here about reliability and validity. So let's say that our friend here takes the test once and gets a 15%, takes it again and gets a 15% again. We would say that that is reliable, right? He has gotten the same score twice, or very close to the same score, so it's a reliable test. If he takes the test once and gets a 15%, takes it again and gets a 95%, we'd say it's not reliable, right? It's not producing a consistent score from test to retest. Okay, let's say our test is screening for performance on some job, and our buddy here gets a 15%, then gets a 15% again. He's hired anyway for whatever reason. Maybe he's got a friend in the company. And it turns out he does really poorly at the job. That would mean this is a reliable test, right? It tests well time to time again, consistently. It's also valid, right? It predicts performance well on the thing it's supposed to. It measures something important and is valid because it's predicting that thing. The poor job performance as a result of a poor score on the test. Valid test. Great. Okay, let's say instead We get a 15% to 15%, okay. And then he does really well on the job, right? He scores poorly in the aptitude test for the job, but then excels while he's in the job. We would say this is reliable, right? Its test to test is the same. It's a consistent test, so it's reliable, but it's not valid, right? It does not predict the thing we want it to. The performance on this test is not at all correlated with performance on the job, so it's an invalid test. Okay, that's it for this time. Next time, we're on to theories of intelligence.